Hello and welcome to this video tutorial of LabVIEW, the new software platform for FIRST Robotics Competition. In this video, we will explore the LabVIEW environment and the basic components that make up a virtual instrument, or VI. VIs are made up of two windows. The first is the front panel, which will contain the user interface. The second window is called the block diagram, and it will contain the graphical code. The front panel contains two basic I/O elements: controls, which are user inputs, and indicators, which are outputs. We connect controls, indicators, and functions on our block diagram using wires. Wires are analogous to variables in text-based programming. Different colors and different thicknesses represent different data types. This is the LabVIEW Getting Started splash screen. From here, I'll open a blank VI. Every VI, or virtual instrument, is made up of two windows, the front panel and the block diagram. The front panel, seen here in gray, contains all of our inputs and outputs and is the primary window our user will interact with. The block diagram will contain our functional code. These two windows contain toolbars which give us control of the execution of our program and also basic editing features. The run continuously, abort, and pause button are used to control the execution of our program and are shared between the two windows. We also have control of our on-screen font and font size. We can also align and reorder our objects on our front panel and block diagram. Debugging tools such as highlight execution and single stepping are only found in the block diagram. In LabVIEW, user inputs and outputs are known as controls and indicators and can be added from the controls palette. We open the controls palette by right-clicking on the front panel. To leave this palette open, click on the thumbtack. I'll now open the numeric palette and add two numeric controls and two numeric indicators. While each of these look different, they all represent the same data type. We can easily customize our controls and indicators by resizing them. We can also change the label text. This is like changing the name of a variable. Our block diagram automatically has icons representing our front panel controls and indicators. Moving these controls and indicators on the block diagram does not change them on the front panel. To add functions to our block diagram, we right-click to open the Functions palette. Again, this palette can remain open by clicking the thumbtack. This palette contains structures and functions required for creating a program in LabVIEW. I can now add this simple add function by dragging and dropping onto my block diagram. Because there are so many functions in LabVIEW, it is beneficial to have additional information and some details about what each one does. The easiest way to do this is by using the context help, which is found in the Help menu, or by pressing Ctrl H. When I mouse over an object, the context help automatically changes to reflect what I am mousing over. If I need additional information about a function, I can click this link, which launches the LabVIEW Detailed Help. This detailed help page on the add function contains additional information about it. If there's a particular function that I cannot find by browsing the functions palette, I can search for it by clicking the search button. I simply type, and our search box automatically reduces down our search results. By dragging one of these search results onto the block diagram, the VI for it automatically appears. Now that we know more about the two windows and the basic building blocks that make up a VI, let's make this program run. To connect our controls and indicators to our function, we use wires. If there's an error in our code, the Run button automatically changes to a broken arrow. By clicking in the broken arrow, we get a list of all of our errors. Here it says, Add, contains unwired or bad terminal. By double-clicking on this explanation, LabVIEW automatically highlights where the error is occurring. Because this add function contains an unwired terminal, we cannot run our program. When I wire up this terminal, our broken arrow automatically changes to a standard run arrow. This program takes the inputs from our two controls, adds them together, and outputs them on our two indicators. I'll now set the values for our two controls, hit the Run button, and their sum is displayed on our two indicators. If we use highlight execution, we can see the data flow and the data moving through our code, and our code functioning. If we click the Run Continuously button, our code runs in a loop. Changes I make to the front panel controls are immediately reflected on our indicators. To stop this, I hit the Abort button. Let's review the important concepts addressed in this video. A VI is composed of two windows, the front panel and the block diagram. The front panel is our user interface, and the block diagram contains our code. Controls are user inputs. Indicators are outputs. These can be added to our front panel, and functions can be added to our block diagram from the Controls and Functions palettes. Both of these palettes can be accessed by right-clicking. Finally, wires are used to connect controls and indicators to functions. This concludes our first video tutorial of LabVIEW. If you have any questions or comments, please post them in the NI First discussion forum. Be looking for the next video where I'll discuss in more detail the concept of data flow.